Welcome back to the channel, guys. We've found ourselves in sunny downtown Ballarat. So what we're doing is catching up with Thomas, the engineer who's behind all the suspension. Update him on where we're at. We've got some repairs to do, and we're looking at what's happening further up the track. So ordinarily I would say come along for the ride, but being in Victorian city traffic, I don't think anybody wants to do that, but your call. Come along, see if we can make it in one piece. I'm pretty sure I would rather be tackling the Madigan line again in the Simpson Desert rather than traffic. But yeah, that's just how it goes sometimes.
Back up that way, past BCM homes. Hey, Nate.
How you going, Thomas?
Good, yourself?
Good, mate. Good.
See ya?
Yeah. We had a lot of fun in that getting down here. I would much rather deal with the rural areas than coming through this city traffic.
Yeah.
Bloody hell.
It's like an amazing trip.
Yeah, we've had a good run. Our biggest issue, and that's one reason why we're here so early, is we've done a front drive shaft in.
Yeah.
So that'll take us back home, and we've got to stay pretty much on blacktop. But anyway, I'll show you what we've done, or where we're at with the trailer. We've packed and stacked it. On this one here, it'll be this stub axle.
Yep.
That's slightly out of alignment. It rode okay, but yeah, it started scrubbing that tyre.
Yep.
Previously, it would have been this one that was scrubbing this tyre. That's the one that we split.
Yep.
Down on the back. But yeah, from what I could see, wasn't a lot of difference in terms of ride and how things, track and all that sort of stuff. I'm able to watch it from the video, or the camera up the top, looking down over the top here. And I thought that with the heavier duty suspension, it may have bounced around a little bit.
Yep.
There was no sign of that, and everything sort of stayed pretty much the way it was inside the trailer. What I look at when it's on the ground and parked up and everything's fairly level is the amount of deflection in the two trailing arms. And I couldn't see a lot of difference between this stuff and this.
Yep.
It all seemed to sit pretty much the same with just a tiny little bit of deflection.
Yep.
I don't know if it's meant to sit differently or not.
It would a little bit, but because trailers have such a wide variety in weight compared to fully loaded, the spring rate's quite a lot higher than what you get on something like a car where it's a much more consistent weight. So when you're underweight on both of them, there's not going to be much deflection on either, just because when you're at full capacity it still needs to not deflect so much that your trailer's, a couple of inches lower than what it would when it's empty.
Yeah.
Yeah.
But it's got amazing, I'll call it articulation. I don't like that phrase. It becomes a bit of a catchword.
Yeah.
But when you see it going over mounds of dirt, you see the two wheels moving around. I've never seen that much suspension travel on a box trailer.
Yeah,
before.
And that's the big benefit to load sharing. We can cheat the spring rate and have a suspension that still performed well, even without that deflection, and trying to get a really nice low spring rate like you can have on a car. Yeah.
Yeah.
we've got a few things that we're looking at changing. So with the torsion bar and the mounting and that cap behind, I've always wanted something a bit more secure there. So we're going to machine a slot into the torsion bar, and that'll mount into a bit of box tube. So that'll run the whole way across rather than having that weak split in the middle. And we'll have greasable bolts there that basically retain that. So that should help seal it as well from having, all the dirt and everything.
Keep all the crud out.
And just makes it a lot easier to integrate into a trailer too, just being able to weld that beam across the bottom and not have to worry about sort of as much of a subframe. So that's one change. Couple of others is with this tube that was split, we're doubling the wall thickness of the outer tube from 1/4 inch to 1/2 inch. So that's a pretty big jump in strength.
That's a huge jump,
and as you suggested, running the 90-degree pins rather than right next to each other, which just helps spread that load on the tube a bit better. Also running a sheet metal brace there, so we can up that to 6mm thick and get a bigger width there, which should just help that stiffness a little bit extra.
That'll stop some of that flex.
Yeah, correct. So that's the main changes for the next model. We are still having a few issues trying to get those stub axles within tolerance. So the other thing that we're developing or testing is a unit bearing. So it's designed to fit between a standard brake drum off a Toyota and your standard brake drum off a trailer. So it'll mount using these 4 points in here, replacing those studs. And then that will sit over and you'll have your wheel studs poking through. So the idea behind that is on the back side, we can shim this bolt pattern with tapered shims. So rotating them will give us a wheel alignment ability, providing that bolt pattern is strong enough for what we're doing. So we've got to prototype that on the way at the moment, and we'll do some testing and then hopefully get it up to you to try out as well. And hopefully that will fix those issues. Otherwise we're just going to have to continue developing better jigs and better bending system to bend those back to where they should be.
So that arrangement there is rated at what, 3.5 tonne? Or will be for a 3.5 tonne?
Correct, yep.
Okay.
Yeah. So we're using a similar bearing to what they use in Europe and a few other companies are doing. They're generally rated at 1.8 tonne per axle.
Per axle.
Yep, so that gives you 3.6 tonne between the pair of them. And they're a sealed for life bearing, so you get really long life out of them.
So they'll be good for boat trailers as well.
Yeah, correct.
If they're sealed for life, because every time you're travelling down the highway, someone has a boat trailer with a bearing buggered on the side of the road. Yeah,
so I've spoken to a few people that service trailers that we work with, and they've said with those bearings, they rarely have to replace them. Most of his job is replacing bearings, and he said he's done one of the European bearings, just because they last so long. We'll also not have any dust caps, so that'll be solid over the front, and just have that seal in the back. So that should keep a lot of stuff out of that as well, because often the dust caps don't seal
with that
too well.
Dimension brake drum, is there an option for a 5-stud thing?
Yep. Yeah, so this brake drum is available as a 6-stud off a Hilux or a 5-stud off a Hi-Ace. They're an off-the-shelf item, so spare parts should be relatively accessible anywhere. The brake drum stays standard as well, and we'll have a 6-stud and a 5-stud option. And beyond that, for any odd wheel bearings, wheel stud sizes, we would be able to custom machine different stud patterns as well at an additional cost. But the 5-stud and the 6-stud covers. Well, they're pretty. Correct. Yep.
Pretty common.
Yeah. Yeah.
Very goodly. That'll be interesting to see just how it all sort of pans out.
Yeah, it'll be really interesting, and it'll be something new as well, and that'll extend to our hydraulic suspension systems and even solid axle leaf springs to give wheel alignment abilities, and later on, and obviously user accessible too. And the other cool thing is that'll be really easy to replace. So if you do a bearing on the side of the road, it's just 4 bolts to put a new one on, and that's it. But the unit bearing will be rebuildable as well if you have a press and want to go down that path.
Yes. Interesting challenges ahead, to say the least.
Yeah, hopefully we can get there. I think we're close. 90% of the way there, but it's just chasing that last 10% to get something that can cross the Madigan line without breaking.
All right, we're back here with Thomas, the engineer. Thomas has been absolutely flat out to do a wheel alignment basically on our suspension unit there. Now this was the one that we had issues with up in the Northern Territory. It was just slightly out of alignment. So he's had it up on his bench and been busy straightening it all up. So right at present, we'll put that up there again, Thomas. We're pretty happy. It's a crude way of looking at it, but we're happy with the alignment of the stub axles and the hubs. You're happy?
Yep.
Sounds good to me. All right. I guess here, if we can just clean up in there, put it back in, I suppose that's the best way to do it.
Yep.
All right, we'll do that. We'll put it all back in.
Sounds good.
We ran a number of different scenarios, I guess, doing pressure and stress, stress and fatigue scenarios on these. And it was interesting. You'd have seen all the way like the mesh overlay over a part on a computer shows up your stress levels and things. With the two pins here, the stress level on this back pin was enormous, absolutely enormous. And it didn't make any difference whether you had the one pin or the two pins. The stress loading on each of them were much the same. But as soon as you turned that at 90 degrees, it changed dramatically. Didn't completely solve any issues. It did change considerably the amount of stresses down on it. But we were also calculating that with a 20 mil pin, because that's what I thought. I thought they were at about 19, 20 mil. So 16 mil, that would increase that pressure considerably.
Yeah. Well, my concern with going too big was that we'd start risking breaking the bar instead. So that seemed to be the best balance of pin size versus how much meat's left on the bar. That is interesting because we did break the single pin, but since we've had the double pin, we haven't broken a pin. We've only torn that tube apart. So hopefully we can reduce that pressure significantly going up to the thicker wall thickness. Going up a thicker wall thickness, when we did that changed considerably. And then having those pins not just opposed, but we spread them further apart. And that helped. The downside to spreading them further apart though... You reduced... Correct. And because that's I believe a squared law, quite a small change there can increase the spring rate quite a bit, which then puts more force back on that pin. That's right. Everything that we looked at, you ended up altering the physics of it, quite rapidly. But what we did come up with, instead of having a pin there, was like a double flange on the back, because that way, with your twisting force, the further you can get that out, the better it is on there. So by having a double flange, the only problem is you put a double flange on there, how do you get it apart? I've been down that path, and also how do you get it in to the trailer? Well, the only thing that you could do would be to have like a saddle in there. And then the other issue is how do you physically make that? So you're back to trying to fit welds and everything on the end there. That's where this is what we're looking at, was the size of the weld. Obviously putting a V chamfer in there, putting a fillet in there with a second fillet, and then probably one will have to be machined to marry up with the other one, and also even putting a slight shoulder or a step on it. Originally we just welded the two together. That was the first thing we tried, and that broke quicker than the pins did. So that's the other concern with doing something like that, or otherwise you have to start from a really large bar and machine a lot of material away. Well, that's what Chrysler did. Exactly that. But the other thing that we looked at, we run it up on the computer
but we didn't end up with any conclusive things, but was to use a multi-spline shaft idea.
Yep.
But and it was one of those things that, and I've seen this happen before on earth moving gear, a multi-spline shaft, when it first fits in, because of really fine points of contact, the loading on that there is enormous until it settles in to increase the surface area that's making contact with.
Yeah. So that's an interesting part that we looked at for the prototype, which I was hoping should be here today or tomorrow. I was hoping it would be here for you to look at, is to use an involute spline. Yep. So an involute spline is a special curve that means that the surface area that's touching is always quite a bit larger than a point of a straight spline. Yeah. So that's definitely an option we've looked at as well. But again, there's some difficulties in packaging that into this really small area. Yeah. So the pins is what we've had the most success out of so far. But yeah, we are hoping to try a few other ideas as well.
One of the ones that we came up with, we didn't do any testing of that on a simulator, was 2 individual torsion bars side by side.
Yep.
One for each trailing arm, because right at present, if they fail like the other one did, both are down.
Yep, but with the load sharing that will happen anyway. So if you had 2 torsion bars, they would have the same load as we've already got on it, so they'd have to be just as big.
If they were...
And if one fails, you'll still lose both sides.
Of load sharing.
But because that's load sharing, if one fails, the other one will be able to rotate back towards it as well.
Yeah,
yep.
yeah.
Yeah, and it's intuitive to think that it's half the load, half the torsion, but it's actually the same load. So that torsion bar would be the same for a single axle as a tandem, because it's the reaction force is what's balancing it out.
Yeah. But it was interesting, all the scenarios and things that you can come up with, and how many different ways you can.
Correct. Yeah, and that's the difficult thing, is trying them all.
Yeah, and some are no better off than the others.
Yeah, and it's a really difficult thing to simulate as well, because what the computer shows you in FEA can be entirely different, especially when you're talking fatigue loading and dynamic loading like this. It can be unpredictable what works and what doesn't.
Oh yeah.
Yeah.
In my experience with earth moving gear, the best laid plans don't always work.
Yep.
Yeah.
Here we go. All right, pop this one in the back. A bit of more grease. Yeah, I think the problem is it wedges itself. Alright.
We've just got to get the shaft engaging in a bush.
That's about right.
You right?
Yep, perfect.
Hang on, there you go. When we had some tyres fitted up there in Alice Springs, the fellow was ex-army as a tyre fitter, and he got the Never-Sees out to put on the studs and that there before put the wheels back on. And when I mentioned it to him, he said, "Don't ever put wheels on without it," he said. Oh, okay. It's messy at times, but where I found it's really handy is when you've got alloy wheels and the wheel nuts fit inside the alloy rims. I've had them a few times there where you're going to take a wheel off and they've been galling inside.
Hopefully that's the last time we have to pull it out for a while.
Thanks for your time and efforts in that there, Thomas.
No, thank you, and thanks for testing it out for us.
Yeah, I'll try not to destroy it, but we'll certainly be giving you feedback as to how it's going, how this one here performs now. And yeah, we will be in touch.
Perfect.
Cool. Love it. Don't forget, if you've liked the content of this video, don't forget to give us a big thumbs up. Okay, we still got some traffic to challenge through Ballarat yet, so thumbs up. Okay, don't forget to subscribe. Cheers, guys. See you on the next one.